next up, the actual CNC conversion itself. So as I mentioned, I went to the UK and I saw a bunch of CNC robots over there, and I really liked it. And as fate would have it, a fella I followed on YouTube for a while, DCT Teacher One, was actually while I was over there, put up a video saying he was selling the Titan TM25V kits, which is what I have. So I pretty much bought one on the spot there, and a couple of weeks later on my return, it was waiting for me. So I think the kit was about $800 from memory. It was a long time ago now, but I mean, the quality of it was just A1, absolutely fantastic. Super happy with it. It came with all of the CNC'd aluminium mounts, all 3 ball screw nuts, the mounts, all the hardware, the motor couplers, the whole thing ready to go. The only thing I had to buy was the stepper motors, which are NEMA 23 570 ounce cinches from Automation Technologies, so they're the 5 amp versions. I think that's pretty much as big as you can go before stepping up to the next size. Probably, honestly, is a bit too big, really. So I reckon this is probably about as big as you can go before you have to take that next jump up in money, and you've really got to ask if it's worth just going to servos at that stage. But nonetheless, I'm super happy with it. He did mention when I bought it that these are Chinese machines, and obviously, you know, things aren't just going to bolt straight on. And he was absolutely right. I don't know if you can see it that well. There we go. It did require a lot of sort of post work, getting all the holes to align, because, you know, Chinese machine, they just drill the holes in by hand. This machine was especially bad, like someone had just gone to town on it with a power drill. Holes were at like 45 degrees and they just bashed random pins in here and there. It was spectacularly awful, but nonetheless, I have access to a round core mill at work, and we got that all slotted and done. It was really non-trivial, actually. I think the worst thing I had to do was drill a few holes in the top of the column for the Z-axis mounts. That's pretty damn easy, really. The only thing I had to do was the ball screw nut mounts for the X-axis that goes on that carriage. There's 2 holes it attaches to, and they were just dramatically off-center, meaning that the whole lead screw was tilted off at a severe angle. So I drilled those out and slotted them, and then changed the mount to be threaded instead of having the bolts go through it into the tapped carriage. So that allowed me to sort of fine tune it all and adjust it, and it seems to be working really well. Absolutely no binding up along the whole travel, so that sorted that. Absolutely no problem with the kit, obviously. That was just a fault of the machine, really. Aside from that, yeah, fantastic. So let's have a look at the rest of it. Cool, so here's some miscellaneous parts. First things first, I 3D printed my own stepper end caps that cover all the wiring. Can't quite see it in this one, but there's actually a cable gland that goes on the bottom of it, and all the cabling runs out. I just printed those as a prototype. I'm going to CNC them out of aluminium, but they work really well. They look pretty neat. Super happy with that. Next up is the inductive limit switches, or home switches, I should say. So this is the X-axis. The switch just mounts to a 3D printed base that bolts on there, and there's a 3D printed cover. It's also an aluminium L-bracket that bolts to the table to cover it. That works fantastic. I haven't had any chips or false triggers whatsoever. And that there is the actual just inductive stop, I guess. It's only aluminium. I was thinking I'd have to make it out of steel, but it's been pretty good and it's really repeatable. So I'll probably just leave it, honestly, until I have any further issues with it. So I'm also going to CNC that out of aluminium at a later date. But this is all very much V1.0, just to make sure it's all actually going to work. Not sure if you can see it, but there's a little U channel bolted in with the Y-axis one. That's very temporary. I've got to replace that ASAP because it actually causes the X-axis to lose a bit of travel. The mount hits it, but that was very temporary because I couldn't really work out a good place for it to go. And that's the Y-axis inductive stop. It's just a big chunk of aluminium. Also seems to work well. The positioning of it, the Y one's actually quite nice because it's covered by the table for the whole travel, so you don't tend to get chips piling up there. And also being horizontal, they just fall off anyway, so I've had no false triggers for either of them, so I'm pretty happy. And also, see all that filth? That's because I use old motor oil to lube the ways. Don't do that, it's pretty nasty stuff. It ruins the paint, so lesson learnt there. So first up, once I got the CNC conversion done, I noticed even with the 570 ounce-inch stepper, there's still a bit of lost motion in the head, a bit of backlash. So initially I thought it was because the head was just too heavy for the stepper. So I've put a pair of 150 Newton gas struts on it, so there's about 30 kilos of upstroke force on the head, which has made it negatively weighted now. So when you hit the down at the bottom of the travel, when you hit the emergency off, it actually pushes the head up, which I guess is good. I'm going to add a bigger motor and some power drawbar stuff later on, so that will probably offset the weight again, so it'll all work fairly nicely. The mounting on top's actually a bit dodgy. I actually had the gas struts the other way up before, which looked a lot nicer, but doing a bit of reading I found you actually have to put the struts this way so the lubricating oil falls on the seal and they'll last a fair bit longer. And that's been working quite nice as well. There's a fair bit of unused stroke, so the force is fairly linear, not totally, but whatever, it does a good job. So this is the bottom mount here. It's just a aluminium block, 2 M6 bolts tapped into the base, and I think that's a M8 that just goes straight through into the rod end joint there. It's all pretty simple. And that on the top is a pair of 6mm aluminium plates that bolt into the stock motor mount, another aluminium block, and then that just bolts into the ball joint on top. Not particularly elegant, but I have to remake these anyway to mount a bigger motor and do the power drawbar, so whatever, temporary, it works for now. So this is the newest edition. The original Z-axis way cover perished, so this is one off a Tormach PC 770, I think. It's pretty much a perfect fit. All I had to do was drill a pair of holes on the top, a pair on the bottom, and it went straight on. When it concertinas down, it actually billows out because the actual dovetail is quite a bit bigger. So I just laser cut some polypropylene and glued it on, and that's worked pretty well. So I'm really happy with that. Okay, so this is probably my favourite piece of all. There's a bit of a story behind it. So I'm 28 now. When I was 16, I used to do Robot Wars with a fellow down in Melbourne called Tim, and he found me 4 of these aluminium billets in a scrapyard, and at the time I'd never seen a piece of metal that large, and I was really enamoured with him, so he sent me 4 of them, and I promised I'd keep them till the day I had a CNC, and then I'd use them for something. So I figured I needed a big spindle lock to work with the Tormach TTS tooling, so this was one of the first parts I ever made. So it's quite large. I think it's about 95mm square by, God, I can't remember how thick. It's about 45 or 50 thick. So there's a lot of deep pockets in there. I did that all with a 10mm carbide end mill. But yeah, nonetheless, really happy with it. So 10mm piece of a hardened rod. All you do, there's a hole in the actual spindle itself. Just pop that in, and yeah, there you go. It stops the spindle from turning. You can undo the drawbar wrench with one hand, hold it with the other. Works super well. So there's just a trio of M8 socket head bolts that clamp it on. I've left there's enough meat under there that I want to add a ring LED on there for a bit of extra light. And there's also a pair of M8 tapped bolts for, I don't know, either a coolant nozzle, or maybe I'll mount a permanent indicator or another lamp or something. But yeah, I really love the look of it. It's pretty awesome. So if you're out there, little Tim, thank you for those aluminium billets all those years ago. So this is another favourite thing on the mill. This is the Fogbuster clone I built based on the patents they released. So I found reference to it on the CNC Zone forum where people had made their own. Because the original one, it's really good and gets rave reviews everywhere, but geez, it's so expensive. So this one owes me about $150 Australian, which is pretty good really. There's really not much to it. So it's just a hollow piece of brass rod, That's actually a 1mm, or is it a 0.8? I can't remember. MIG tip that I just soldered on, and that's a brass block. That's the very first thing I CNC'd with this machine. So let's see if we can have a closer look. Alright, so there's just a push fit in the back, and a Ligris needle valve on top. Geez, those were so hard to find. I couldn't find them on eBay or anywhere, especially in Australia, so I ended up paying something like $30 for it, which is pretty much one of the most expensive parts of the project. But geez, really nice parts. So I'll show you the rest of the system. So here it is. So it's all pretty simple, really. That's just a water filter cartridge, just standard style. You can get it from the hardware shop. I think I bought it from some online eBay filtration shop or something like that. So air comes in through the coiled hose to a small solenoid valve I picked up for like $2 off eBay or something. 24 volt coil goes up the spiral cord into a low pressure regulator. I got that one from RS, it's SMC brand, and geez, it was really oddly cheap. So I think that one actually regulates up to about 15 psi or 20 psi, and it's set for about 10 or so. So you need a lot of resolution. You can't use your standard style, unfortunately. So the air flows into this T-piece. So the air goes into one of the fittings, which we'll go back to. The other part of the T flows into this, and that's where the coolant is. So there's actually another hose that goes all the way to the bottom, and then that flows up out this end. So in the Fogbuster system, what makes it fogless is that the actual coolant is also under the same pressure as the air, which apparently stops it atomizing. So here's the outlet for the filter cartridge. It's all a bit awful, but hey, whatever, it works. So there's a large, I think it's 3/4 inch BSP fitting into another push fit into a check valve, and that's just to stop the coolant flowing back. So when the CNC tells the solenoid to open, you're not waiting, 5 seconds for all the coolant to flow back out through the long lines. That works very well. We're very happy with it. So I'll show you where the fittings terminate back on the Fogbuster. Okay, so this one here, that's just the straight compressed air from the T-piece, and this top one, that's where the coolant, compressed coolant comes in. So the liquid actually goes through this needle valve, and that's where you adjust it. So how do I like it? Love it so far. It's so good. The whole time I've been using it, for like the last month, that's about as much coolant as I've used. So probably about, I don't know, 800 mils, a litre. There's probably about 10 hours worth of CNC time, and I've had that thing like on a lot more than it really needs to be. So good. The compressed air just blows those chips out, and the amount of lubrication, it seems spot on, even though it's actually using very little liquid. So yeah, I will probably eventually go to flood, but for now, yeah, this is super duper sweet. There's like next to no mess as well. Just awesome. And finally, there's another CNC mount that I made that replaces the quill handle, which is all gone now. This is just some Delrin that I laser cut out with my laser cutter. This is a new version I made of it actually. So it's actually got slots, so you can adjust the angle for all the different sizes. So it works a lot better with things like fly cutters and slitting saws and tiny drill bits and whatnot. It's a lot more universal. Just a pair of little adjusting knobs with flanged nuts on the back. Works really well. So yeah, that's my Fogbuster clone system.